Alkyne nomenclature follows the same rules that we have been using for alkanes, alkenes, and alkynes, and is most similar to alkene nomenclature in the sense that we're naming a molecule that has a triple bond instead of a double bond. Exactly. There we go. For example, if we have a chain of 5 carbons with an alkyne at one end, we're going to name the longest continual chain of carbons, which is 5. So it's pentane. Pentane becomes pentyne for the triple bond. And we give the triple bond the lowest possible numbers, which in this case is 1 and 2. And so we name this 1-pentyne. Let's look at a couple of examples together. Here are 2 molecules, one shown as a structure, one shown as a name. See if you can come up with a name for the drawing and a drawing for the name. In the first example, we find the longest continual chain to be 1, 2, 3, 4, 5, 6, 7, 8 carbons long. So we have an octyne. And notice that with the geometry of the alkyne being linear, it can be difficult to spot where it starts and ends. And so we need to be aware that we see a single bond and then a triple bond and another single bond with bends in the line, that there's a carbon at each of the ends of the triple bond, in addition to the bends in the line and the intersections of lines and the ends of lines that we're accustomed to seeing with regular skeleton structures. So we'd say octyne, and let's put the number between the T and the Y this time for variety's sake. We can start numbering to give that triple bond the lowest set of numbers. Means that it's going to have 3 and 4. So it's oct3-ine. And if we keep numbering, we'll find that on the number 7 carbon we have a methyl group. So we have 7-methyl oct3-ine. If we're going to draw a large ring, we can freestyle it, or if we're having trouble, we might consider at least starting with the defining functional group, which is our octyne. Notice there's no number, so we're assuming that the triple bond is going to have the lowest possible numbers 1 and 2. And that's 2 out of 8 carbons. So we need 6 more. We can simply draw 6 dots and then connect those dots, and we'll end up with something that looks roughly like a stop sign. And then we number along to find the number 4 carbon, where in this case we have 2 vinyl groups. And remember that vinyl is an alkene as a substituent. So we have 2 of those here.